you all for being here today, and finally thanks to Luminex Corporation for putting on this great event. Devils and the Diluents, you'll see what that means in just a minute. That phrase was actually coined by a vice president of ours. I told him that if the business part of it ever didn't work out, he'd have a good second career in marketing. He didn't laugh at that. But, as you may have guessed, I am not Elena Peterson. Elena was scheduled to do this, but she got a little held up, so you got me instead. Biotechnic Corporation, of course. We have a table over there. You can see some of our brands. I work for R&D Systems, located in Minneapolis, Minnesota. It's one of the Biotechnic Corporation companies. So what we're really talking about today is managing interference in immunoassays. Immunoassays are subject to lots of different problems that can come with the sample. What I want to talk today, obviously, is based on our Luminex assays, and showing you how smart assay design can really manage those interferences, and failure to manage those interferences can dramatically affect your results in terms of accuracy. So as by way of a short outline here, common serum interference in immunoassays, I'm going to show a few examples of those, the effects that interference from these compounds can have on accuracy of your assay, and how we at R&D Systems fix that. So these are just a couple of examples. By no means are these all of them, but I'll just run through a couple here. You can look at interference by compounds in a two-side immunoassay, whereas you get interference by the capture antibody here. Something is essentially blocking it from capturing its target. Conversely, a similar compound may block the detection antibody, and you would failure to detect there as well. There are antibodies that are present in serum samples that can also have a similar effect, in which case they can bind to either one of the antibodies. In this case, the detection, in this case, the capture, so you can kind of get an idea of the sort of effects that they're going to have. These are mostly probably going to manifest themselves in terms of a false negative value, but I did want to show one example of a pretty dramatic effect that we see. HAMA and RF, these are human anti-mouse antibodies, and RF is rheumatoid factor. So these are heterophilic antibodies that are relatively common, more common than you probably think in human serum samples. But how this can interfere in assays is that, oops, I'm sorry, not the first time that's going to happen probably, is that they have an affinity for IgG. So what they will do is they'll actually bridge. This isn't a very good cartoon, but I think you kind of get the idea that in the absence of any analyte, let's say there's really no detectable level of analyte there, you can actually get bridging of the capture and the detection, and that's going to manifest itself as a false positive result. So you can see, this is real data. In terms of IL-1 beta here, if the RF were present, in this case we quench the RF reaction. And if it were not, you get a very, very high value, so that's going to be a very misleading result. Yeah, false positive, there we go. So the devils and the diluents. Really, this is the mechanism that we use at R&D Systems in our assays to manage those interferences. We spend a lot of time optimizing these diluents. Of course, if you've developed multiplex assays, you understand that this can be very challenging. So you basically have one set of reagents, diluents, that have to work for multi-analytes. So how do you make that balance? We spend a lot of time making sure that we can manage things like matrix effects. That's that kind of general interference term that we hear a lot. It means a lot of things, but there are some very specific things that we need to deal with too. Interfering factors such as binding partners, soluble receptors, and of course I mentioned human anti-mouse antibodies and rheumatoid factor. So besides managing those interference, we also have to ensure that the assay gives accurate results in terms of recovery, linearity, inter-assay and inter-assay precision. So we want to be able to provide a good assay for you, obviously. So we spend a lot of time developing these diluents and making sure the assays work in the end. So we can't say exactly what's in those assays, or in those diluents. They're kind of trade secrets, but suffice it to say that our most recent assay, I think it probably took about 14 to 16 months for us to develop and make sure that it hit all of our specifications. So this is really my last slide, but there are other confounding compounds other than heterophilic antibodies or binding partners. There are binding chaperone proteins. Proteoglycans can have a great effect on certain analytes you're trying to measure. Some of them bind specifically to things like heparin. Complement components, believe it or not, they are really designed to fix IG. Biotin is one that's come to light a little more recently, I think, with a missive from the FDA on biotin interference in immunoassays. And there are probably a lot more out there that we've yet to discover. Citrulline proteins can become antigenic and create heterophilic antibodies as well. And that's all I have. And I want to thank you for your attention.